Okay, we're on this section of polar coordinates and parametric equation. Certainly, we covered the lecture material. We talked about graphing, both by hand and using computer. We talked about how to, what a parametric function might look like, and we went through some examples. We did talk about deception. We're going to try to prevent that deception from occurring. We talked about probably the worst way to do something is by tables. However, it does work. Nothing wrong with it. Tables are a little bit tough for a lot of students, though, and they're computationally very frustrating for some students. Again, we're not trying to trick you, but there are some tricky graphs over here. I did talk about these technology. I talked about Mathematica and Wolfram Alpha. And I'm certainly going to say that there's other software out there that you're more than free to use. You probably want to start using software at some point in your careers to make life a little bit easier when it comes to doing really tough mathematics. Not easy stuff, though, by the way. So when we do problem set, my claim over here, oh, by the way, we give you good pictures of what polar graph paper looks like as well. And you're free to use that. You can just print that out if you want. All right, it's easy, really easy to do. Print it out and use it. All right. So what are we going to do now? We're going to go to the. I'm going to scroll through this. I know we gave you a lot of families here. I'm not asking you to memorize. All right. It's good to read though and try to understand. Some teachers ask you to memorize. I'm not a big fan of memorization. I would rather have you reason through this stuff if you can. So we're at the point in the notes where we talk about this material. It's a long section. We want to start doing examples. All right. So I'm going to switch over to the whiteboard. And just give me 1 second. All right. And let me go backwards and see where we are. We're at number 1. All right. So, just looking at number 1, it says consider the following. They want me to graph it. And there's nothing wrong with doing a table. But the way I'm going to graph this over here, I'm going to look at it. And I'm just kind of looking at what they've given me over here. And I think I probably could graph this pretty rapidly just by looking at it. And it's a parametric function, number 1. So what do you got? You got x equals t. And you get y equals t over 7. If you're going to make a table, though, I want to point out the table would have 3 things in it. T, an x, and a y. I'm going to say 0 would be the easiest number to choose for t. Would that give you 0 for x, 0 for y? Now, a lot of people say, what's the next number you choose? I don't think I would choose 1 because I'd get a fraction. I would choose the number 7. What do you get for x? 7. And for y, you get 1. Now, yeah, what's another number to choose? I'd probably say minus 7. And what would you get? Minus 7, minus 1. I think you get the idea that you could do tables. And if you kept doing the table, you're eventually going to get dots, and those dots are going to connect up somehow. 14 would be good. Minus 14 would be good. Oops. You get the idea. What do? You plot the points out down. What points you plot out? 0, 0, 7, 1, minus 7, minus 1, 14, 2, minus 14, 2. I think if you did that, you would see that they definitely line up. That's certainly one way of doing it. Another way of doing it is just simply eliminating the parameter. And if you did that, what would you get? Well, I'm going to say you would get y equals, what's t? It's x over 7. Right now, you should realize this is an equation of a line with slope 1/7 and a y-intercept of 0, 0. Right, let's look at the picture. And I got the picture over here. I'm just going to point it out to you. It's definitely an equation of a line. I'm seeing that. X-intercepts 0, 0, y-intercepts 0, 0, and a slope of 1/7. All right, let's read the rest of the questions. And I'm doing that. Eliminate the parameter. I've done that already. Maybe by chance, but we've done that already. It's right up here. And certainly graphing was pretty easy. Domain and range of this thing here. So what I'm going to claim domain and range is, look at the graph. Right, this is the graph. What's the domain of that? Well, the domain of that would be all real numbers. In interval notation, minus infinity to infinity. And the range of this is going to be all real numbers again. or minus infinity to infinity. All right, whoops, sorry about that. All right, let's go to the next page. And the initial problem, pretty easy to do. I'm looking at it, and again, if you were, whoops, sorry about that. If you were looking at this thing and someone says, what are you going to do with this thing over here? I'm going to look at it, and I know it's a parametric. X is defined in terms of some parameter t, and y is defined in some parameter t. What I would do, I don't think I would do a table, but there's nothing wrong with using tables. All right, so I'll put the table down for you. And if I'm going to graph it, there's three things in the table, and that's going to be t, x, and y. And I'm going to say probably t to be 0 would be easy to do. So if you did it, what do you get for x? You get 1. All right, what would you get for y? 5. What's another easy number? Probably I'm going to choose, I don't know, 1, right? Like 0 to 1. What'd you get for x? 0. What would you get for y? 5. Then I might go to 2. What would you get for 2? Well, for x, you get 1. And what do you get for y? Well, if it's 2, you get 2 plus 4, which is 6. All right, and that, to me, it's a little tedious, but it does work. Let's choose 2 to be minus 1. What would you get for x? You would get 2. Minus 1 is minus 2, but the absolute value of that is 2. Then you get 3. All right. If you were to plot these points, I don't know, 0, 5 is pretty easy, right? Right here. 1, 6 is pretty easy. Right there. 1, 5 is easy. Right there. I'm just plotting points, by the way. 2, 3 is easy. You get the idea, right? You could plot points. Now, I'm not saying you know what it looks like, but you could plot those points out. All right, so plotting points, nothing wrong with that. All right, I want to eliminate the parameter now. And to do that, I'm looking at y, and I'm going to say y can be solved for t. I'm sorry, that y equals t plus 4 could be solved for t. So I'm going to write that down. So t is going to equal y minus 4. And then I'm going to plug that into the first equation. The first equation is x equals the absolute value of t. T is y minus 4 now, right? And minus 1. And this looks pretty easy. What do you get? X equals y minus 5. Now, for me, this is much easier to graph out. Much easier to graph. If I were looking at this one over here, I'm going to say it looks really simple to graph. It's an absolute value function. And certainly, if y is 5, x would be 0. And it's an absolute value problem. Looks sort of like this over here. All right. Not much else in that. I guess I could do this over here as well. Let's extend it out. Let's see if we can get this point over here. And that's x is 0. All right. X would be 0, right? I'm not x is 0. I'm sorry. Y is 0. What am I saying? If y is 0, what do you get there? You get 5. All right. Again, if you look at the picture, they give you a good picture. It's better the picture I'm giving you here, but you get this over here. And I'm certainly seeing that point. All right, let's see if we can answer the questions now. It says eliminate the parameter. I've done that by chance. It's right over here. I see that. What's the domain and range of this guy over here? Also pretty simple. Look at the picture. What's the domain of this thing over here? The domain is the x must be greater than or equal to 0. If you want to put that in interval notation, that would be 0 to infinity. What's the range of this guy over here? It's all real numbers, right? All the real numbers. What does that mean? Minus infinity to infinity. Just look at the picture. You'll see that. Right, stuff that you studied in Math 119. Let's go to the next question. And this is a little bit more difficult. So this is number 3. And I'm going to push it on the side. And what does it say? Consider it. I don't think I want to do tables. But however, before I do that, I want to claim it's a good idea to know what x and y could be by looking at them. So if I write this down, if I write down x equals e to the 2t, and I write down y equals 2e to the t, you should be quite clear that x is always going to be greater than 0. You should also be quite clear that y is always greater than 0. So the graph of this thing is always going to be in the first quadrant. It's always there, right? Always in the first quadrant. Then my question becomes is, what is it going to look like? I would like to eliminate the parameter. Now someone says, could you solve that for t? Well, going back to 119, you could use logs. But what am I noticing over here? That x is actually equal to e to the t squared. And e to the t, for, you know, if I get that y down there, is really just y over 2. All right, so let's write this down. X equals, this elimination of a parameter, by the way, y over 2 squared, which is going to be y squared over 4. Well, I hope you realize that this is a pretty simple equation. You get x equals y squared over 4. Unfortunately, if you weren't thinking about the problem, you could graph it. I'm not going to deny it. And if you graph this thing out, what you look at a picture like this over here. Right? The problem. Unfortunately, this would be a wrong answer. So let's talk about why it's wrong. Why is it wrong? If you look at this over here, the x and the y must be positive. So I got to get my eraser out and do that. I'll put that down for you. And I'll put this over here, my axis down. I'll put my graph down. It looks like this. The circle here. Why is it a circle? It can't touch that point. It just can't touch it. All right, what does it really look like? A root function to me. All right, let me write that down for you. That if you wrote the root function down, what are you going to get? You get 4x equals y squared. Again, if you just think about what you did in Math 100, y would equal plus or minus the root of 4x. This is incorrect because y cannot be negative. So what's y really equal to? 2 root x. That's all it is. That's the function. All right. And my question over here is, you know, domain and range of this guy over here. Well, x must be greater than 0. And the range of this, the y must be greater than 0. What does that mean? 0 to infinity. 0 to infinity. All right, clearly the graph, you know what? I'm not really seeing that hole there, but it is there. I'm seeing this over here. We got this over here. And I'm seeing the domain and range over here. All right, let's go to the next page. And I'm sorry, I shouldn't say the next page. Yeah, the next page. I'm sorry, you're on the next page. And let's talk about it. And next page, what do we got over here? We got a series of problems. They're smaller problems now. And what does this one over here say? You know, number 4, and we'll talk about this in stages. It says convert the rectangular point. I want to point out what this means. X equals minus 5 and y is equal to 5. What I would recommend is, at least initially while you're learning this, to draw a picture of what this looks like and understand what it means to go be in polar form. So I'm going to draw a picture of this thing, and I don't know, it doesn't look too bad to do, like minus 5 and 5 here, something like this over here. So I'm going to say there is an angle theta here, all right? And, you know, looking at it, you know, what's the angle there? Well, you'd have to know trigonometry to know that. And, you know, the reference would be 45 degrees, right? So what's the angle? The angle is 135 degrees. Or if you prefer, you want to go to radian measure, what's that going to be? And I think it's just looking at a picture is going to be 3 pi over 4. What's the other thing we're looking for? We're looking for that, that distance from the pole, and this is over here. And what is this going to be? There's going to be some length of this thing over here. And what's the length of that? And again, it goes back to trigonometry. That's pretty simple. We call that the radius, right? Whoops. Sorry about that. Get my eraser. Okay, so the R here is going to be, let's see, that's going to be, it's like a 45, 45, 90, and you got the sides being 5, 5, so 5 root 2s. Okay, how are polar forms written down? And they're written down as an ordered pair. The ordered pair is R, comma, theta. Now, by the way, I'm not going to say there's only one answer here, but I want to give the most obvious answer. What's R? 5 root 2, comma, theta, which is 135 degrees. If you want to write down radian measure, that would be 3 pi over 4. Both are acceptable. All right. Degrees are probably a little bit easier to deal with. I want to point out there's some relationships you should know. I'll write them down for you. X squared plus y squared is equal to r squared. R could be a negative number, by the way. What's x squared? We're looking at is 25. What's y squared? 25. What do you get over here? Well, you get 50 equals r squared. And again, in polar form, r could be plus or minus. So r is plus or minus root of 50, which is plus or minus 2 root 2. This is where students get horribly confused. That's why I'm saying a picture is going to be helpful. It's going to be really, really helpful. At least you'll be able to ballpark where the angle is. And if this is a nice problem, it'll be really easy to do. All right. But anyway, there's other forms to put down. We'll get to that. Okay, this one says convert the polar point. So then the question goes, is the polar points given to me? I'll write this one down for you. So the polar point is minus 3, comma, 135 degrees. All right. So I'm going to point out r is minus 3, and the theta is 135 degrees. Well, the first thing I would want to do here is I want to visualize it. Okay, when I'm visualizing things, I'm going to tell you what I look for as the angle first. I know what that is. The angle, I'll put this over here. This is the angle. It's 135 degrees. All right, that's pretty simple. When I'm looking at that, what's the reference? 45 degrees, right? And then the next thing I look at is I look at the directed distance. Now, I want to point out 135 is in this direction over here. But what do they want me to do? They want me to go in the opposite direction 3 units. So let me put that down for you. So that point's over here. All right. So this length over here is 3 units. Here comes the problem. I'm looking at it, and I hope you realize that just by looking at it, you should have a really good idea what that point is. Let's go through it. Give a little triangle down. As I do that, my triangle over here, I know that this side over here is 3. What's this angle over here? It's 45 degrees. So I'm pretty comfortable. I've got a really nice reference triangle, but I'm looking at it. I'll tell you what I'm looking at. I'm looking at the x coordinate, and I know the x is a positive number. I'm looking at the y coordinate. I know that's a negative number just by looking at my picture. And that's why pictures are so important to a large number of students. This is 45, 45, 90. What am I doing over here? And again, I hope you realize what you're doing over here is I'll look at the reference triangle for you. That's a 45 degree. Typically write down 1, 1, root 2. And if I did that, I'd probably want to scale it. And I'll put down what I mean by that. 1 over root 2, 1 over root 2, and 1. And then multiply by 3. And you get 3, 3, 3. All right, so let's write down x. What's going to be 3 over root 2. And the y is going to be minus 3 over root 2. So I'll write the point down for you. 3 root 2, comma, minus 3 root 2. All right, I'm going to do it a different way. I'm going to do it by formula. Again, formulas are fine. I want to warn you against formula that people get terribly confused and everything becomes a memorization thing. And we don't want you memorizing a lot of stuff. So let's write this down. What's x going to be equal to? X is going to be equal to r times cosine theta. Y is going to equal r times sine theta. Let's write this down. What's r? It's minus 3 times cosine 135 degrees. What's r? Minus 3 times sine 135 degrees. I hope you realize that this is a pretty easy computation. Cosine of 135 degrees is going to be minus 1 over root 2. Minus 3 times minus 1 is 3, so it's 3 over root 2. And what's the second one going to be? It's minus 3 times 1 over root 2, which is minus 3 over root 2. Are we getting the same answer? Of course we are. The answers are listed for you up here. Let's go to the next one. And again, it's basically, do you know what you're given and know what they're asking for. They say a point in polar coordinates is given. So I'll write down what this means. It means that r is 4 and theta is 3 pi over 2. I'm going to visualize that for you. All right, as I visualize it, someone says, do I need to visualize this thing? Well, maybe in your head, but on a paper, it's fine, but you should visualize it. What do we do? Angle first, 3 pi over 2. If I did that, what do I do? It's something like this. I got the angle down, and then the directed distance is 4 units. What does that mean? I got to go in the direction of that angle 4 units, all right? And that's the point, all right? What do they want? Find the corresponding rectangular coordinate of that point. Well, I'm looking at it. It's going to be really simple to do. And what is that point going to be? Well, the x coordinate is going to be 0, and the y coordinate is -4. Let's say you want to use a formula instead. X equals r. What's r? R is 4 times the cosine of 3 pi over 2. And y, this is a formula, is 4 times the sine of 3 pi over 2. All right? What are you going to get for y? -4. And what do you get for x? 0. Are we getting those things? Of course we are. All right, let's go to the next one, number 7. And it says use a calculator to find a rectangular coordinate xy of the given polar coordinate. Let me write this down for you. So they tell me x is, no, they didn't tell me x. What did they tell me? They told me r. All right, let me go back. They told me r is 7.8. And they told me theta is 2.65. By the way, I'm still going to visualize it. And someone says, why do you want to visualize it? Not because I'm going to get an accurate picture of it, but I do know that there's an angle been given to me of 2.65. A lot of people misunderstand this, think I'm talking degrees. We are not talking degrees. We're talking radian. And where's an angle 2.65? It's going to be over here somewhere. All right, 2.65. Again, if I went all the way to the the axes, the x-axis in the negative direction would be 180 degrees or minus pi. So like roughly 2.65. And then you're 7.8 units out from the origin. All right, but I could not locate that point by looking at my picture. So what I'm going to write down? I'm going to write down the answer for you. And I'll write this over here. X equals r times cosine theta, and y equals r times sine theta. Let's write this down. What's r? 7.8. 7.8 cosine 2.65. Sine 2.65. This is radian. There's no unit. Must be radian. If you do this on a calculator, and we want to recommend it, you do the 7.8 times the cosine of 2.65 and you're in radian mode, you should get minus 6.88 to the nearest 100th. If you do y, which is 7.8 times the sine of 2.65 in radian mode, you will get 3.68. All right, what's the point going to be? X minus 6.88, comma, y 3.68. And again, we're rounding it to the nearest 100th, 2 decimal places. All right, let me just say, I think I did, let me just see if I did all the problems. And I can look at my own notes here. I'm just going to scroll through them. I think we're on number 8 now. Let's go to the next page. And number 8. All right, let's take a look. Number 8, plot the point given in rectangular coordinates. I'm going to put this down for you. Should be easy to do. Let's take a look at it. And what are you going to get? You can get a point, rectangular coordinates, and the point's over here. All right, what's that point? 0, comma, minus 9. It says find 2 sets of polar coordinates for the given points. One's pretty easy to do. I'll do this one over here. I'll go directly to the point. What's the angle here? Theta is going to be equal to, let's see, that would be 270 degrees, right? Or you could put down 3 pi over 2 if you prefer. All right. What's the r? Well, we're going in the direction of that point, so it'd have to be 9. So let's write that point down for you. So it's going to be r, comma, theta. So r, 3 pi over 2. That's one point. I'm going to put another one down. I'm going to go here, right? So line's going up like this. But I got to go in the opposite direction now. What's the angle? The angle there is going to be, let's see, that's pi over 2. But I have to go in the opposite direction, which is going to be minus 9. All right? Those answers are clearly listed over there for you. 9, 3 pi over 2, and minus 9 pi over 2. All right? They want me to keep the angle between 0 and 2 pi, by the way. Let's go to number 9. It says over here, convert the rectangular equation to polar form. Here's the deal, though, and I want to emphasize this to you. This is a really simple problem. I want to emphasize that this over here is an equation of a circle. It's centered at the origin and has a radius, it's the center, and has a radius of 8. All right, now they didn't ask for that. They said convert the rectangular equation to polar form. Well, I got something pretty simple. X squared plus y squared is equal to r squared. All right, so what do I got over here? X squared plus y squared is the same thing as r squared. And what's r squared? It's 64. All right, I'm going to keep reading, and I want to point out what I'm reading over here. R has got to be a positive number. So I now can solve this. And what's r going to be? R is 8. It's still an equation of a circle centered at the origin with a radius of 8. All right, that answer is listed over here. Let's go to number 10. Number 10, really simple equation. I want to tell you what the equation is. An equation of a line. It's an equation of a line. And what they want me to do is write this as a polar form. Let's write this down. X equals r cosine theta, and y is equal to r sine theta. Okay, let's write that down. 7 times x. What's x? R cosine theta plus 9 times y, and that's r sine theta, minus 5 equals 0. By the way, there's nothing wrong with the way it's written, but I'll be honest with you, a lot of people look at it and say, why would you write it that way? Typically, we try to solve for, well, if we're in a Cartesian system, we would solve for y, right? Like, for example, this equation over here, solve for y, you get 9y is equal to minus 7x minus 5, and then you divide through by 9, you get y equals minus 7 ninths of an x minus 5 ninths. Again, that's for Cartesians, if that's what you would have done, at least what some students would do. But I'm telling you, in your polar system, we try to solve for r, if it's easy. If it's not easy, we don't do it. Let's take a look at it. So I would probably factor out r from this, and what do you get? R times 7 cosine theta plus 9 sine theta. I'm going to add 5 to both sides, and I think I can solve for r now. What's r going to be equal to? 5, 7 cosine theta plus 9 sine theta. Same answer. All right, not bad. Let's take a look. I think we're done with that. Let's see, 8, 9. No, there's 10 somewhere. 10's up here maybe. Oh, no, we just did 10. What am I saying? We're going to 11. 11, let's take a look. 11 is the graph, the polar. All right, so I'm going to point out a couple of things I want to make sure you understand what you're doing over here. Is one is polar equations for a lot of students are very difficult to consider. You could do a table if you want. What I want to do is I want to talk about just rewriting them. And to rewrite this guy, I'm going to put it on his side for you. And I'm seeing r equals 9 cosine theta. What I would do, and you may say this a little strangely, I want to get it into Cartesian form. The way I'm going to do that, multiply both sides by r. You would get r squared equals 9r cosine theta. Now, r squared is just simply x squared plus y squared. And 9, and what's r cosine theta? It's just x. So what do I get over here? I get an equation of a circle. I'll write this down for you. X squared minus 9x plus y squared is equal to 0. I'm going to complete the square. You would get x squared minus 9x. Well, what's 1/2 of 9? 9 halves. You get 81 quarters. 81 plus y squared is equal to 81 quarters. What do you get over here? X minus 9 halves squared plus y minus 0 squared equals 81 quarters. This is an equation of a circle. I'll write this down for you. The center is going to be 9 halves, comma 0, and the radius is 9 halves. You learn circles both in Math 100 and in Math 119. So I'm going to just, look at my picture over here and plot the point for you. Where's the center? 9 halves. What's 9 halves? It's 4.5. And where's 4.5? Right here. Okay. What's the other thing? I got 4 points on the circle. And what are they? They're 9 halves away from, when I say 4 points, it's 4-point technique. 9 halves away. A point up here, point down here, point over here, point over here. Let me list the points for you though. Again, if the center is this, and I move 9 halves away from the center in those 4 directions, what are these points going to be? Well, this point over here, if you're at 9 halves, you move over 9 halves, that would be 9 halves plus 9 halves, which is 9. So that's 9, 0. What's this point over here? That would be 0, 0. How do I know that? If you're at the point 9 halves, 0, and you move left 9 halves, it's point 0, 0. What's this point over here? Well, it's 9 halves. I haven't moved left or right from the center, but I have moved up from 0. That would be 9 halves. That's 4.5, by the way. What's this point over here? I'm still at 9 halves. What's the other point you get? Well, we move down 0 from 0 to 9 halves units, so it's minus 9 halves. What do you do here? Draw a circle in if you can. I'm drawing a circle over my own circle there. Put this over here. So I'm going to say this one was easy. No troubles there. It was easy. All right. I didn't need a computer for that. Go to the next one. And that's going to be number 12 now. And this is number 12 over here. I got to be honest with you, number 12 might prove to be really difficult for some students, but I still want to go through what we'd like you to try. All right, so I'm going to look at number 12 and what we'd like you to try. And what we'd like you to try is just to rewrite it. And that's a problem. I want to tell you what the problem is with it. One of the problems is you might say, oh, I'll multiply both sides by r, just like you did before. And what would you get? You get r squared equals 3r plus 6r cosine theta. Well, r squared is x squared plus y squared equals 3r plus 6. Well, r cosine theta is x. I've got troubles now. And I'll tell you what the trouble is. 3r. I got to get this thing in Cartesian. So I'm going to say this looks like it might be tough. All right? But I could keep writing it. I'll tell you why. What I could write down is x squared plus y squared is equal to r squared, which means r is plus or minus the square root of x squared plus y squared. You should realize now that this thing is really getting crazy difficult. So 3 times plus or minus the square root of x squared plus y squared plus 6x. I'm going to say for most people, they can't recognize this. They look at this thing, have no idea what it is. It's this thing over here. So what I want to do is I want to talk about software. And again, we're not asking you to memorize things, all right? So one software I want to talk about is Wolfram Alpha. I'm going to claim Wolfram Alpha. It's really easy to type this in, and we'll do that later. We'll go back over that, all right? What I want to do now, though, is just talk about the next guy over here. And again, looking at it, I've got more troubles. I've got double angle formulas now. So someone says, what do you do there? Well, I guess I was going to rewrite this guy over here. We'll go to software later. I'll write this one over here for you. And this is, R equals 2. Oh boy, I got to write this down now. What would I get over here? 2 cosine squared theta minus 1. All right. Let me just review that with you. Cosine 2 theta, identities, right? Cosine squared theta minus sine squared theta. And if you put that down as another identity, right? You could write down, let's see, cosine squared theta, and sine theta is 1 minus cosine squared theta, which would give you 2 cosine squared theta minus 1. That looks pretty good. So let's write this down. R equals 4 cosine theta minus 2. All right, what would you do now? Well, I guess I can multiply both sides by r. And if you did that, you get r squared equals 4r cosine theta minus 2r. Okay, what's r squared? X squared plus y squared. And what's 4r cosine theta? It's 4x cosine theta minus 2r. I got problems still. And I'll tell you what the problems are. I'm still not in the Cartesian system. And the more I go through this, the more difficult it looks like it's going to get. Like you could multiply both sides by r again. That would be 4x r cosine theta minus 2r. And if you did this, what do you get? Well, what's r? We just did it before. It's plus or minus the square root of x squared plus y squared. X squared plus y squared. This is 4x. Well, r cosine theta is another x. That's x squared minus 2 times plus or minus x squared plus y squared. This is just getting crazy difficult. And I'm going to say it's pointless. All right, so going to Cartesian is kind of almost a waste of time. So I'm going to say, like, when you take later courses, you probably want to recognize what this one is here. But listen to what I'm saying. I'm not going to ask you to memorize this. I'm just going to say that going to Cartesian system is just going to be too painful. So at some point, your teacher's going to say, oh, you should recognize that guy. Again, I'm not a big person on recognition. I'm much bigger on understanding. And we'll talk about software later to get there. So let me take a look. And I'm going to go right now back down to a different share with you. And I'm going to forget my whiteboard at this moment. And I'm going to go to another share with you. And let me just take a look at this, all right? So we now are looking at the problems that we just did. And let me just point out that we up to 10, we didn't use any computers whatsoever. No, I guess I did. I used the computer to do some calculations. But for the most part, my claim over here is that I would like to be able to do a problem like number 11 using software. So let me just, briefly go through Wolfram Alpha. So I want to point out we're at a website called wolframalpha.com. And what's nice about wolframalpha.com, it's fairly easy to use. Like I could just type in plot or graph. Let me put the word graph in. And I could say R equals 9 times the cosine. Whoops, cosine, sorry. I shouldn't have said whoops. Just, I don't even know where theta is on the keyboard. Type in the word, Theta. Hit return. And what are you going to get? Let's see what you get. You get a circle. What did I get? I got a circle. All right, that one was pretty easy. Let's do the next one. Again, I'm using Wolfram Alpha. We're trying to encourage you to think about using software. And I'm going to do number 12 now. And I got part of it typed in, so I'm going to type in that. And what's going to be 3 plus 6 star cosine theta. And again, if you don't know where theta is in your keyboard, just simply type in the word theta. And what are you going to get? You can get a picture. The picture I get, that's a picture I'm getting over here. You may want to think about that. And it's good if you are going to start thinking about that. All right, let's go to the next one, which is going to be number 13. And number 13 looks pretty tough. And I'll write down for you. And again, we're trying to get you to use software. That's going to be 2 cosine of 2 theta. So I'm going to put 2 star theta. Let's see what we get. Gee, we get something that looks like a flower, right? There we go. All right. I'm going to talk about another software product. For those students running a computer that runs the OS 10, I'm going to recommend that you use a software called Grapher. All right, let me open up Grapher for you. And one thing I like about Grapher is it really allows a good deal of flexibility in what you're going to be putting down over here. So I'm going to put down this one over here, which is R cosine 2 theta, right? Put this over here. R equals 2 cosine, 2 star theta. So I type in the word theta, it actually put the symbol in, and you get this over here. One thing I like about this software over here, it allows me to manipulate this thing much more quickly than I can in Wolfram Alpha. I also want to point out as you move forward, which we are hoping you're going to be moving forward, you may want to start thinking about the quality of graphs that this is going to produce. For example, let me give you an example. And I can move this thing around pretty quickly. I'm sure you've seen that over here. Pretty simple. Don't worry about what these functions are. Let me give you another example. Again, really simple. I'm pulling that around with my mouse, by the way. Really simple. All right, let me do another one. I'm just going to some basic examples here. Do not worry about this, though. I'm just saying there's a lot of software out there, lots of it. All right, really high quality stuff too, though. All right, this actually comes built in with the operating system. All right, examples. Let me see if I can do that. Real simple. You know what I'm doing, pulling things around. All right, let's keep going. Look at another example. Oh, let's do this. Let's do this one. Let's do 2 more. You see, pulling around, get a nice little view of it. Just do one more example. You get the idea. Software is really nice to have. Learn to use software. Learn to use software.